even though this section refers to inverse functions, we're not going to start off talking about functions just yet. So let's slow our roll a little bit. We're going to talk about a relation first. So this is a more general version. For any relation R between two variables, say x and y, the inverse of that relation, written R with a little negative 1 exponent there, is a role reversal between the variables x and y. So let's take a look at inverse relations 3 different ways and get a feel for what we're talking about here. The first way that we can look at this is by the data, or what's called numerically. And so what we have here is the following. If R is this collection of ordered pairs, 2, 3, negative 2, 5, 7, 2, 8, 3, and 0, 6, then the inverse, R inverse is how that is read, is nothing more than a simple role reversal of the ordered pairs. So this would be 3, 2, 5, negative 2, 2, 7, 3, 8, and 6, 0. And all I'm doing there is I'm switching the x values for the y values and vice versa. So let's see if I can make this look good. I want to make this look good. Okay, it's a little sloppy. Getting there. And let's see. The 5 to the 5, the 2 to the 2, the 3 to the 3, and the 6 to the 6. So we're just swapping. And as it turns out, we see another relationship emerge. So for R versus R inverse, since we're switching the roles of x and y, we get a complete role reversal of the domain and range. If we look at the blue values for R, the domain is 2, negative 2, 7, 8, and 0. And that corresponds exactly with the range, 2, negative 2, 7, 8, and 0, of output values for the inverse. And the range of R, which is the purple values, 3, 5, 2, 3 we won't repeat, and then 6, are also the same as the domain values for R inverse, 3, 5, 2, and 6. So again, we have this role reversal between values. So the domain becomes the range, and the range becomes the domain. So the range of R inverse is the domain of R, and vice versa. Okay, so that's just some basics. The next thing that we want to talk about is inverses graphically. So I'm just going to draw a random curve here. It's pretty random. There we go, something like that. You'll notice what I did not draw was a function here. So this will be our relationship R, and I want to show you what the inverse looks like. Now, really what we're going to do is we're just going to go back to the same idea over and over again, that we're doing a role reversal between x and y. It's what we did here. Switch x and y. And it's what we're going to do here. And there's a bunch of different ways that we can talk about that. One way to do it might be to actually put ordered pairs on here. This is, oops, the ordered pair is 0, 4. This is the ordered pair, negative 3, 4. Got any more good ones here? Let's pretend that that one hit exactly at negative 2, 0. This one's a nice one at negative 3, negative 2. Got any more good ones? Maybe that one looks like whole numbers there. Let's go 2, 5 there. And for the sake of argument, I should maybe draw this a little bit better here. Let's see, what do we got? Let's make this go a little bit further, and let's call this right in the middle at 1, 2, 3, 4, 5.5. 1, 2, 3, oops, 4. 4.5, 4.5. Let's call that one 9 halves, comma 9 halves. So if we wanted, we could just do a role reversal of these ordered pairs. No big deal. This ordered pair was negative 3, 2, so that'll be now negative 2, negative 3. And let's see, as we go through this, 0, -2, 4, -3, 4, 0, 5, 2, and then this particular point doesn't actually change. And that's an important idea for us, actually. The inverse of that point is itself. So when are the inverse points not going to change? Well, anytime y equals x, the ordered pair x comma y will equal the ordered pair y comma x. Or more importantly, any point that ends up on this line is fixed relative to this inverse operation. And this makes this look like the axis of reflection right here. So if I draw that inverse curve, oh, missed that. Let's try that again, Jenkins. I could have done better there, but you get the idea. This is our inverse. It's mirror image, and that's just a simple role reversal. The other way to do this is to, and I don't know if I can draw this very well, but if you want to think about it like this, here, let's see if I can do this. And we'll do something silly for our graph. So our graph is a happy face with his hair curling towards the y-axis. So if we're going to do a role reversal of x and y, we're going to take y and we're going to make it the x-axis. So let's see what happens there. So if this was the positive y direction, this is the positive y direction, but that makes this the positive x direction now if I rotate by 90 degrees, and then this will look, oh, that hairdo's not quite right, is it? Something like that. But not only do I have to make the y the x, it actually turns out now what was the y is now negative x, and so what we're going to have to do is we're going to then have to flip this top to bottom, and what we're going to get now is this is being the positive y direction, this is the negative x direction, and this is the positive x direction, and now we're going to get our happy face there. And so if you want to think about it graphically, we're going to rotate 90 degrees to the right, or I shouldn't say to the right, I should say clockwise. Clockwise, and then reflect over the x-axis in that order. 1, rotate 90 degrees. 2, reflect, and you will get the inverse graph. Okay, so there's some stuff graphically. Let's not harp on that too long. And then analytically or algebraically, if I have something like y equals 2 plus x over 3, the inverse of that relationship, we're going to switch x and y wholesale, and so this is x is equal to 2 plus y over 3. And that's the inverse relation. And if you want to solve it for y, resolve for y, you can. That'll be 3x is equal to 2 plus y, or y is equal to 3x minus 2. And these are inverse relations. This is the inverse relation. And we'll talk more about that in the coming examples.